Imagine the digital world as this sprawling, interconnected city, and right in the middle, these vast, powerful, kind of mysterious structures, the cloud platforms. Today, we're opening the case file, really digging deep into how the three big architects, Google Cloud, AWS, and Microsoft Azure, how they actually stack up.
Right. And our mission here, it isn't just, reading off a list of services. It's more like digital forensics. We want to cut through all that noise, uncover the connections, the similarities, yeah, but also the really surprising differences between these giants. We're
Hmm.
basically trying to give you, the self-learner, a shortcut. Turn that info overload into something you can actually use. Actionable insight.
Exactly. And our key piece of evidence for this investigation, it's a detailed comparison document, updated December 3rd, 2024, straight from Google Cloud itself. Think of it like their own internal assessment, laying out the capabilities side by side. It's our roadmap for today.
Yeah, it's a great starting point. And we'll be looking at, well, pretty much everything. From the basic building blocks, the compute power, all the way up to the really advanced AI, the stuff that can, create things. We'll cover security too, how they guard the gates and the tools you need to actually build and move your stuff into this digital city. It's about demystifying it all, one service at a time.
Okay, so the cloud. It's massive. Where do we even start digging? I guess we have to begin at the foundations, right? The bedrock. Compute, storage, and networks. Everything else is built on top of these. What's the first clue here when we look at these basics across the big three?
Well, the key thing to grasp, I think, is that while they all offer powerful tools, their, let's say, design philosophies can differ slightly, especially around efficiency and specialization. Let's start with compute, the digital engines. These are your basic virtual machines. Google's Compute Engine, Amazon EC2, Azure virtual machines, they all do the job. What Google often emphasizes with Compute Engine, for instance, is maybe faster boot times or things like live migration, keeping your apps running during maintenance. Features like auto-scaler, adjusting resources automatically. That's pretty standard now, thankfully. Critical for managing costs on any platform.
Right, auto-scaling is table stakes. But pushing the envelope, let's talk specialized power, the stuff driving all this AI we hear about, beyond the standard VMs.
Yeah, this is where it gets interesting, especially for machine learning. All three are heavily invested here. Google has its cloud GPUs and cloud TPUs, tensor processing units. These are purpose-built to just crunch through ML models way faster. AWS has its own families, like Trend 1 for training, NF1 for inference, the newer P5 instances. Azure has its ND series VMs. They're all throwing serious silicon at AI, and even the operating systems are getting specialized. Google's container-optimized OS, AWS Bottle Rocket, these are stripped-down, secure OCs just for running containers efficiently.
Makes sense. Okay, you've got the engines running. Now you need somewhere to keep all the evidence, the data, the digital vaults,
Yeah.
storage.
Absolutely.
Yeah.
And the fundamental concept here is object storage. Take Google Cloud Storage, AWS S3, Azure Blob Storage. Perfect for just vast amounts of unstructured stuff. Images, videos, backups, you name it. Store anything, retrieve it whenever. But then you get more specialized. For the VMs themselves, you need faster block storage. That's Google's Hyperdisk, matching Amazon's EBS Elastic Block Store and Azure Managed Disks. Reliable, high performance, and sometimes you need a shared file system, like the old school NFS. Google offers File Store for that, fully managed. Amazon has EFS, Azure has Azure Files, similar concepts across the board.
Okay, compute storage now, connecting it all, the invisible pathways, the network, the city's road system. How do they get content to users fast wherever they are?
Yeah, global reach is key. Content Delivery Networks, or CDNs. Google uses its planet-scale cache network for Cloud CDN and Media CDN. The idea is to cache your content close to users all over the world for super fast loading. Amazon CloudFront and Azure Front Door do the same thing. It's all about reducing that lag, that latency.
Makes sense. And what about businesses connecting their own data centers, their own networks, into the cloud? Or linking different cloud regions?
That hybrid connectivity is crucial for many organizations. You need reliable, secure pipes. So Google has Cloud Router for dynamic routing, Cloud Interconnect for those dedicated high-speed links to your own network, and Cloud VPN for secure tunnels over the internet. You see direct parallels everywhere. AWS has Transit Gateway, Direct Connect, and their VPN. Azure has Root Server, Express Route, and VPN Gateway. Different names, same fundamental goal, secure, robust connection.
Got it, but pathways need protection. What's the first line of defense? How do they stop the bad guys trying to break down the doors?
Security is obviously huge. Google Cloud Armor, it comes in standard and enterprise tiers as their web application firewall, or WAY. It protects against denial of service attacks, web exploits. AWS has its WAF and Shield services. Azure has its Wave and DDoS protection. They're the perimeter guards, basically. But
Yeah.
then you go deeper. Google offers Cloud Next Generation Firewall. That's looking for more sophisticated threats, intrusions, malware, command and control traffic. And Cloud IDS, the intrusion detection system, is constantly scanning network traffic for suspicious patterns.
Okay, so we've laid the foundation. Now the investigation gets, well, more intelligent. We move to the forensics team. AI, data analytics, automated workflows. This is where data starts talking.
Precisely. And at the heart of Google's AI story is Vertex AI. It's their unified platform. Training models, hosting them, deploying them, both predictive and increasingly generative AI. It's a central hub, competing directly with Amazon SageMaker and the Azure AI platform. What's really generating buzz within Vertex AI Studio are the generative models, Imagen for images, Veo for video, Lyria for music. We're talking AI that can actually create novel digital content. It's not just analyzing anymore.
That's kind of mind-bending. Creating video from text prompts. Wow, how does this trickle down into things we might interact with more directly, like chatbots?
Good point. That conversational AI piece is big. Google's Dialogflow and their newer conversational agents tech let you build those lifelike virtual agents. Amazon Lex, Azure Conversational AI, they're all in this space. It definitely makes you wonder sometimes, are you talking to a person or a very clever bot? And beyond just talking, AI is developing specialized senses. Document AI pulls data from forms and docs automatically. Vision AI understands images. Natural language AI gets meaning from text, speech to text, text to speech, translation AI. Each one is like a specialized skill. And AWS and Azure have their equivalents: text-tract recognition, comprehend on AWS, document intelligence, computer vision, text analytics on Azure.
And what about the people building all this, the developers? Are there AI assistants helping them build the AI?
Oh, absolutely. It's becoming a huge productivity booster. Google has Gemini Code Assist and Gemini integrated into Google Cloud itself. Think of them like AI pair programmers. Amazon has a Q developer. Microsoft has GitHub Copilot, which heavily leverages Azure. They help write code, debug, answer questions. It speeds things up considerably. And sometimes AI gets applied to very specific critical tasks, like Google's anti-money laundering AI, AML AI. It's an API designed to spot financial crime risk more effectively with fewer false alarms. A very concrete use case.
Okay, so AI is generating insights and even content, but where does all the raw data live, and how do they sift through potentially massive amounts of it? Data analytics, databases,
Right.
the evidence lockers?
Right. For the massive data warehouse, Google's flagship is BigQuery. It's serverless, scales incredibly well, and works across multiple clouds. It uses standard SQL, which many analysts know, and Google often points to a lower total cost of ownership compared to rivals like Amazon Redshift or Azure Synapse Analytics. It's where you analyze petabytes of data for patterns.
And for data that's constantly flowing in. Real-time stuff, events streaming from apps or devices.
Yeah, for that constant flow, Google Cloud has PubSub. It's a messaging service designed to ingest huge volumes of streaming events. Highly scalable. And Dataflow is the tool to process that data, whether it's streaming in real time or processed in batches later. It unifies both approaches. Amazon's Kinesis data streams and Azure's event hubs plus Stream Analytics play similar roles. It's all about handling data in motion.
It sounds like there's a tool for every kind of data. What about the actual databases, beyond the big warehouses?
Oh, the variety is huge. You've got document databases like Firestore, great for flexible schemas. Bigtable is a NoSQL database built for massive scale, think large analytical or operational workloads. Then CloudSQL offers managed versions of popular relational databases. MySQL, PostgreSQL, SQL Server, easier than running them yourself. AlloDB is a PostgreSQL-compatible database that Google claims offers much higher performance for both transactions and analytics. And then there's Spanner, a globally distributed relational database that scales like NoSQL but maintains transactional consistency. Really unique tech. AWS and Azure have their own rich ecosystems, of course. DynamoDB, Aurora, RDS on AWS, Cosmos DB, SQL database on Azure, Firebase Data Connect also uses Cloud SQL in the backend, and one more Dataproc Metastore. It's basically a managed Hive metastore for tracking your data lake metadata, similar to AWS Glue data catalogs. Yeah, a database for almost any conceivable need.
Okay, we're entering the final phase of our investigation, the security detail. Guarding the assets, overseeing the operations, this feels like the high-stakes part.
It really is. You can have all the best features, but if it's not secure, none of it matters. So first up, Identity and Access Management, IAM. Basically, who gets the keys to the kingdom? Google Cloud IAM, Identity Platform for Customer-Facing Apps, that's CIAM, and Identity Aware Proxy, IAP, for secure access without VPNs. They all control who can access what. It's fundamental. AWS has its own IAM Identity Center, Cognito for users. Azure has Azure Active Directory, now Entra ID, and App Service Authentication. foundational security.
And the keys themselves, the encryption keys that protect the actual data.
Those need Fort Knox level security. Google provides Cloud KMS, Key Management Service, and Cloud HSM, Hardware Security Module. The HSM uses FIPS 142 Level 3 certified hardware that's a very high standard for cryptographic operations. Cloud EKM even lets you manage keys stored outside Google Cloud. AWS KMS, Azure Key Vault offers similar capabilities. But then there's confidential computing. This is really cutting edge. Services like Google's confidential VM and confidential GKE nodes encrypt data while it's being processed in memory.
Whoa, wait, so not just at rest or in transit, but while it's actively being used.
Exactly. It protects against very sophisticated attacks, even potentially malicious cloud provider insiders, though that's extremely unlikely. AWS has Nitro Enclaves. Azure has its confidential computing options. It's a major security advancement.
Okay, that's impressive. Now, how do you keep an eye on everything? The digital investigators, threat detection, seeing the whole security picture.
You need a central dashboard. For Google Cloud, that's Security Command Center. It gives you that high-level overview of your security posture, risks, compliance status. Amazon has Guard Duty for threat detection and Security Hub for the overview. Azure uses Microsoft Defender for cloud. Then you get into active threat hunting. Google Security Operations provides SIEM, that's Security Information and Event Management, and SOR, Security Orchestration, Automation, and Response. These tools ingest security data from everywhere, correlate it, find threats, and help automate the response. Think Amazon Security Lake or Microsoft Sentinel in the other clouds. They're the nerve centers for security teams.
And being proactive, finding weaknesses before they get exploited.
Crucial. Google leverages Mandiant's expertise here. Mandiant Attack Surface Management helps discover all your internet-exposed assets, things you might not even know you have. And Mandiant Hunt provides continuous threat hunting by their experts. It's like having elite cybersecurity detectives constantly on the case. On a more routine level, you need logs. Every action leaves a digital footprint. Cloud audit logs track user activity, API calls. Cloud logging aggregates logs from all your services for analysis, essential for compliance, troubleshooting, forensics. AWS CloudTrail and CloudWatch logs, Azure Activity Logs, and Monitor Logs serve the same purpose. You have to have good logs.
And if something does go wrong operationally, like an application slowing down, diagnosing those operational crimes?
Yeah, performance forensics. CloudTrace helps you pinpoint bottlenecks in distributed systems, see where requests are slowing down. And Cloud Profiler analyzes your code's resource consumption CPU, memory helping you optimize it. Essential tools for keeping things running smoothly.
Okay, last chapter in our case file, the journey and the tools. How do you actually get your stuff into the cloud, and what do developers use to build once they're there? The migration and the workshop.
Right, the great migration. Moving existing workloads can be tricky. Google offers tools like Migrate to Containers and Migrate to Virtual Machines to simplify moving apps and VMs from, say, AWS, Azure, or your own VMware setup. For just moving massive amounts of data, there's Storage Transfer Service for online transfers over the network. Or if you have truly huge amounts, petabytes, you might use Transfer Appliance. They literally ship you a secure hardware box, you load data onto it, ship it back. Sometimes physics is faster than the internet.
Seriously, they mail you a hard drive.
A very big, very secure box of hard drives, yeah.
Ah.
AWS has Snowball, Azure has DataBox doing the same thing, and Google Cloud Migration Center acts as a hub to plan all this, discovering what you have and assessing how to move it.
Okay, so you're in. Now, the Artisan's Workshop. What tools do the builders, the developers, actually use day to day?
Well, the foundation is the SDK Software Development Kit and the CLI command line interface. Google Cloud SDK is the collection of libraries and tools to interact with all the services programmatically. AWS and Azure have their own SDKs and CLIs naturally, essential for automation and scripting. Then for writing code, you have IDE integration. Cloud Code plugs into popular IDEs like IntelliJ and VS Code. Cloud Shell gives you a command line and basic editor right in your browser. And Cloud Workstations provide fully managed, customizable development environments in the cloud, like having your powerful dev machine accessible from anywhere. AWS Toolkits, Cloud Shell, Cloud9 are similar offerings. Azure has its toolkits, Cloud Shell, and integrates with GitHub Codespaces. And finally, for non-coders, there's AppSheet, and lets you build business apps with little or no code, using spreadsheets or databases as a starting point. Democratizing development, really.
Wow. Okay. We have covered a lot of ground. So let's try to summarize this for you listening, the self-learner who's followed us through this whole investigation. We've navigated this incredibly complex city, uncovered the capabilities of Google Cloud, AWS, Azure, compute, AI, security. The sheer range of tools is staggering.
Yeah, It really is. And this deep dive, it's not just ticking boxes on a feature list. It's about trying to understand the blueprint of the modern digital world. For you, that knowledge is, well, it's powerful. It's that shortcut to being able to build, secure, and innovate confidently in a world that absolutely depends on this stuff. You've now got a framework, a way to investigate any cloud service you encounter.
Exactly. A framework for investigation. I like that. And maybe a final thought to leave you with. In this world where the cloud's power just keeps expanding, where data flows invisibly, where AI can generate things we've never seen, what new ethical or operational mysteries are we solving? And maybe more importantly, what new ones are we creating for ourselves down the road? How will your understanding of these systems, now that you've dug into them, shape the digital world you help build? Something to think about.